based on elasticity. We know elasticity, that is, all the bodies are, when subjected to some deforming force, then they change their shape and size because of the deforming force applied to them. And when this force is withdrawn or removed, then they regain back to their original configuration. These bodies are called elastic bodies, and the property they behave is called elasticity. So this elasticity, different types of elastic bodies are there. Nobody in the universe or in the nature is perfectly elastic or perfectly plastic. All the bodies in the nature lie in between these two limits. When elastic behavior of a body decreases, its plastic nature, plastic behavior increases. So there are certain terms here which comes in our experiment. This Young's modulus is simply the ratio of longitudinal stress to longitudinal strain within elastic limit. As according to Hooke's law, we know that within elastic limit, stress is directly proportional to strain. So here there comes longitudinal stress and longitudinal strain. So stress, we know that restoring force, internal restoring force, which is set up inside the body for unit area of cross section, that is the stress. And different types of stress we have already studied, that is tensile stress or longitudinal stress, compressional stress, hydrostatic stress, tangential stress or shearing stress. Similarly, different types of strains that we know, longitudinal strain, and that longitudinal strain comes here. So volumetric strain and shear strain. So the ratio of strain to strain is a constant which is given by Hooke's law, but this experiment is within elastic limit, we have to keep in mind. Elastic limit, simply it is the maximum stress applied to a body within which the body regains its original configuration when the deforming force is withdrawn. So it is simply the maximum stress. Below this, it comes back, above which if it exceeds the elastic limit, then it goes to plastic behavior. So we have to perform this experiment within elastic limit, that we have to keep in mind. So this Hooke's law, as it is told, stress divided by strain is a constant, and this constant is called modulus of elasticity, that we know, or coefficient of elasticity, you can say. So this modulus of elasticity or coefficient of elasticity is constant for a given material. It doesn't change. If the material changes, then only it changes. But this moduli changes if temperature changes. Suppose temperature is increased, then this moduli gets decreased. Only it depends on temperature. So, but if the material is same, then this modulus doesn't change. So it is constant for a particular material. That is why we are finding Young's modulus of the material, of a beam, by bending it. So As different types of moduli we know, Young's modulus, Bock modulus and rigidity modulus. That is Young's modulus, it is the modulus of elasticity of length. Similarly, Bock modulus, it is the modulus of elasticity of volume. And similarly, rigidity modulus, that is the modulus of elasticity of shape. So different moduli that we know, and it is constant for a particular material. So what is Young's modulus? Young's modulus, which we will determine, denoted by capital of Y, that is the ratio of longitudinal stress or to longitudinal strain. So that is this longitudinal stress, if I take force per unit area F by A divided by longitudinal strain del L by L, then it becomes FL divided by A del L. So this is the Young's modulus. So how this Young's modulus comes into play in this experiment? As the beam is going to bend when it is applied some load at the middle. So the basis of the experiment is elasticity by Hooke's law. We have to do that. And number two, in our experiment, the principle of cantilever is working. We know that cantilever at our previous classes, cantilever. So what is a cantilever? Cantilever is a beam, a long beam, whose initial end, one end is fixed and the other end is free. When it is loaded at the other end, then it comes into an arc because of the load given at the other end. So that is a cantilever. So a long beam, we have to take it, whose length is very high in comparison to breadth and thickness. That is why the word beam comes. So whenever the term beam comes, we have to think that it must be a long, rectangular or any rod, steel or iron, whatever, different material, whose thickness and breadth is very much less in comparison to the length of that body. So, but when cantilever comes, then one end of the beam becomes free and other end is loaded. So when it is loaded at the other end, then it comes into an arc. It takes the shape of an arc because of the restoring force or reactions taking place at the fixed end. So we will come to our experiment where the principle of cantilever works here, but here two inverted cantilevers is working in our experiment. If we know the principle of cantilever, then there will be no difficulty to understand this double cantilever in our experiment. So we will find it by doing it or by bending it, applying some load at the middle. So this is our objective of the experiment. So what apparatus we require in this experiment? Next is apparatus required. Here a long beam, number one. Number two, that is spherometer arrangement. Number three, bracket, that is horizontal brackets, or we can say knife edges. Number four, slotted weights. Number five, a key, one-way key. Number six, that is a battery, dry cell or dry cell, which provides a constant EMF. Next is rheostat. So next is vernier caliper. And some patch cords or connecting wires. Connecting wires. So these are the apparatus required in our experiment. With these things, we will perform our experiment to determine Young's modulus of the material. So here the material is steel. The material we use here, that is steel. And we will find it. Next part, that is theory. So there is a working formula to determine the value of Y by bending the beam. So we can see here this beam, which is placed horizontally on two knife edges K1 and K2. These are the two knife edges, that is brackets, table brackets or horizontal platforms, or you can say knife edges, over which this beam rests. It is kept exactly horizontal. At the two ends, these two knife edges are present, and it is placed symmetrically. Exactly the middle of this beam, it carries a small hanger to which some load is given. So when load is given, what happens? It becomes an arc. The beam takes the form of an arc. That means it gets stretched or compressed on two sides. Young's modulus of the beam becomes mgLQ divided by 4 BDQ delta. GLQ divided by 4 BDQ multiplied with m by delta, that can be found from graph, where m is the mass given to the body, delta is the depression because of this mass m, g is the acceleration due to gravity, L is the length between the two ends, that is AB, and B is the breadth of the beam, that can be found using a vernier caliper, and D is the thickness or depth of the beam that can be also found using a vernier caliper. So we will find this using this working formula. So this is the working formula used here to determine Young's modulus of this material. So here in the diagram, before we go to the experiment, whatever arrangement is set up here, that arrangement is depicted on the whiteboard to understand more clearly. So here this is a beam which is of length 1 meter, uniform area of cross section, and it is kept symmetrically and made horizontal. Symmetrical in the sense, on both sides of the midpoint, the distance will be same, because load will be provided exactly at the middle. That is why this beam is kept symmetrical. Then a spherometer arrangement is here to toss this small hanger through which the load is applied, and there is a circuit. When the load is given, we will see the blinking of light when the circular scale is rotated. This spherometer is having a circular scale of 100 divisions, and there is a linear scale very close to it. So with respect to the linear scale, which is near the circular scale, the line that coincides, any line which coincides with this linear scale, that gives us the reading. So after the load is put exactly at the middle, the beam gets depressed, and we will wait for some time. Then after, we will rotate the circular scale in clockwise direction. When it will just touch the small hanger, you can see the glow of light here. A LED is connected in the circuit with the help of a key and a battery. So the other end of the circuit is coming to the, that is, beam or the bracket or the knife edge. So there is a resistance given to see the proper glow of light or proper current passing through the circuit. So this arrangement is made in this experiment, that we will see, and we will take the readings by providing the loads one after the other. So very carefully we have to measure the value of this length that I have already told you, length of the beam, which is the distance between point A and B, that can be measured very accurately, because this third power occurs. If slightly it is disturbed, then entire value of Young's modulus gets changed. Similarly, in denominator we can see there is a third power of depth or thickness. So any error that we make while measuring with the help of a vernier caliper, that gives a high value of error in finding the Young's modulus. It will hamper the entire result. So we have to be very careful while measuring length and D especially. Then we will come to our experiment following a proper procedure. So the connection is just done like this, and we can see here the entire beam, it is a rectangular shape made up of steel of 1 meter length, uniform cross-sectional area, whose breadth is also same everywhere, and some thickness is having. from this end to the other end, the entire length is 1 meter, and it is graduated with 1 cm. That we can see. There are lines drawn on this surface of the beam with 1 cm apart from each other, and it is written with 5 cm. So this end is 50, here it is written 45, 40, 35, 30. In this way it comes down, and the middle point is 0. So from 0 onwards on both sides 50 cm, and everywhere with 5 cm it is written. And this is a beam. So this is the vernier caliper, and we know the least count of this vernier caliper, we can say slide caliper, is 0.1 mm. Before we use its least count must be found out. So least count is 0.01 centimeter. With second order, we will find the breadth and thickness. So, as in the working formula, B, that is breadth, and D, that is thickness, comes. So we have to measure first 2-3 observations, then we will find its average. So at 3 different positions, we will find 3 observations, then we will find the average. The position of vernier 0 over the main scale, that gives the value of MSR, main scale reading, in centimeter. So after keeping both the lower jaws very close, within which this beam is kept, it is made tight, then taken out, then we can see what is the value of this MSR by taking the reference of vernier 0 over the main scale. It gives exactly vernier 0 is present in between 2.5 and 2.6. We have to take the reference of vernier 0. So this vernier 0 is present exactly in between 2.5 and 2.6. So we will note down a MSR, that is main scale reading, 2.5 centimeter. Then next is the vernier coincidence. It is a number on the vernier scale which number of line exactly coincides with any line over the main scale, that is our vernier coincidence. It is simply a number. Which number of line on the vernier scale is coinciding perfectly over the main scale, with any line over the main scale that may coincide. So which particular line of that vernier coincides? That is vernier coincidence. So here, this vernier coincidence, we can find 5. We can see the 5th line is very much coinciding with any line over the main scale. So this is vernier coincidence. As it is a number having no unit, so we can write 5. 5th line is coinciding. Then next comes VSR, that is vernier scale reading in centimeter, which is VC into LC. LC means least count, which is 0.01 centimeter. So when it is multiplied with VC, it gives us 0.05 centimeter. Then when we add these MSR and VSR, that is 2.55 centimeter, which is the breadth of the beam. Now, in this way, we will take three observations at three different places of the beam. Then we will find the average value that will be more accurate. So, next comes that is the thickness or depth of the beam. So, we can see here Vernier 0 is present in between 0.5 and 0.6. Vernier 0, we can see here the MSR here 0.5. This is for D. This is for B. So 0.5 is exactly with respect to the Vernier 0, and VC is 0 because 0 mark of Vernier coincides with 0.5. Both are collinear. So we can write VC 0 and MSR 0.5. So as a result, VSR becomes 0 because VC is 0 multiplied with LC, that gives 0, and MSR plus VSR, it becomes 0.5. So 0.5 centimeter, that is the thickness or depth of the beam, and breadth is 2.55 centimeter. So in this way, at three different places to get three observations, once at the middle and other two observations at two ends of the beam can be taken. Then after we will find its average to get the accurate value of breadth and thickness. So very carefully you have to find mainly this thickness because the third power is present in the working formula. Then we will come to the arrangement as according to the circuit connections given in the diagram on whiteboard. We will connect here, then we will place the beam horizontally on the knife edges with a particular length in between these two knife edges. Let us take the length that is 76. In between these knife, we can take any desired length, whatever it is given to us. Suppose we will take 76. So entire length of the beam is 100 centimeter. To keep 76 in between these two knife edges, what to do? You subtract the value 76 from 100. That is 24. Divide it by 2. That is 12. So 12 cm or 12 divisions on both sides, you keep it out. That means it is very much clear that all the lines are graduated with 1 cm. So from the extreme end,
सबको डाटा मिला?
यस सर।
यस सर। अभी फास्ट
Yes,
फोटो
sir.
फिलअप करो।
ठीक है सर।
मोर किसी हेल्प दरकार सर?
ना सर मु करे देबी। ग्राफ बेले जदी टिके दरकार हबो।
ठीक अछि सर।
फास्ट टू टेबल फिलअप करो जल्दी। फिफ्टीन 38 हुआ है, 15:42 को स्टार्ट करेंगे सेकंड वीडियो, सेकंड पार्ट। तुम्हारा लिस्ट काउंट कितना है? 0.01, ठीक है।
यस सर।
कौन सी representative body है? हो गया कंप्लीट? अरे कंप्लीट हो गया?
थोड़ा एक मिनट सर। सर अप टू 2 प्लेसेस डेसिमल तक लेंगे ना वैल्यू?
यस यस, लेट। तुम्हारा लिस्ट काउंट है 0.01 ना, तो अप टू 2 डेसिमल।
ओके
सर।
बोलो।
सर वो जो लास्ट में लिखा है ना ब्रेथ ऑफ द बीम, वो सर जो मीन आएगा वो वही वाला होगा ना?
हाँ हाँ
ओके सर।
सर टेबल 2 भी फिलअप करेंगे अभी?
हाँ, एक साथ थिकनेस एंड ब्रेथ दोनों को फिलअप करना है।
ओके।
सर एक्सेलरेशन ड्यू टू ग्रेविटी 9.8 ही होगा ना सर इसमें?
ना 980 सीजीएस में कैलकुलेशन करना है, 980 लेना है।
ओके सर।
तो सेकंड पार्ट वीडियो रन करते हैं, ठीक है? क्या बोल रहे हो?
ओके सर।
हाँ सर।
And it is 50, so it is written 45, then it is 40, then so 10 divisions is equal to 10 cm. Now 2 more lines we can take, that is 40 here, this is 38. So this mark is 38 and the other side also 38. This position of 38 will be placed on the knife edges on both sides so that it will be symmetrical. So 12 divisions or 12 cm is taken out on both sides, and in between these the length is 76. So the middle point is the position 0, and from 0 onwards on both sides the length is 38 centimeters. Altogether the length is 76 centimeter in between the two knife edges. So carefully you have to keep this length, otherwise this will hamper the entire result of the value of y as the third power is present in the working formula. So after you keep it, let us take this small hanger that will be kept exactly at the middle, that is at the position 0, to which we will provide the loads to get the depression in the beam. The spherometer will be kept over this small hanger without the contact over it. So with the help of a battery, dry cell, rheostat and a key, all the connections are made as according to the diagram given below. Now, without the load, we have to find the condition of the beam. Before we provide any load, we have to see the condition of the beam. Then after, we will find the depression after we provide each load. Here, I have already told you, these are the loads. This is the long hanger, which is 500 gram, and other 5 loads, each 500 gram, will be provided, one after the other. And when we will provide the load, we will wait for some time. We should not take immediately after we provide the load. When load will be given exactly at the middle, then this beam gets depressed downwards by getting some depression on providing each load, so that the point A and B is elevated upward due to the restoring force, internal restoring force acts on it. And that elevation at point A and B on the knife edges is equal to the depression acting at point C, or exactly at the middle where load will be provided. So now we will put the key to make the circuit close, and everywhere we have to be ensure that connections must be fully tight, otherwise it may fluctuate, this bulb may not glow. So everywhere connections should be made tight. Then we will rotate the scale in clockwise direction. When you rotate it, after some time you will see that the central leg here will contact to the small hanger. So the moment it makes a contact, we will see a glow of light here. That means it indicates that the circuit is closed and we should not rotate more. Otherwise, it will give us the error. So without load, we have to first find, because for zero load, dead load, we have to find the reading first to know the condition of the beam. So let us rotate it clockwise. I am rotating clockwise. As we see the glow of light, we should not rotate more. Now, what is the reading over the circular scale with respect to the linear scale? That means the division of the circular scale coinciding with this edge of the linear scale, that is the reading that we will note down. That is our initial circular scale reading I. So there is a table for that, and we have to note it down. Now I am rotating the circular scale to see the glow of light. Now it is blinking. Now a constant glow gives. We will stop here and we will note down the reading of the circular scale. That reading is initial circular scale reading. And here the reading comes, that is exactly at 25. So 25 is initial circular scale reading. We will note it down. The final reading will be also the same, that is 25, because we have provided no load to the hanger. So both initial and final will be same. Whatever it comes, that we will note down. Here we got initial reading 25 and final reading also 25. Now we will provide in the second observation 500 gram load, that is a long hanger. This hanger is 500 gram, that will be provided in the second observation. So before we provide the load, the reading is 25. So initial reading for second observation will be noted down as 25, because at this condition we will provide the load when the reading was 25. So initial reading for the second observation will be 25 before we put the load here. So we will provide the load here to the small hanger. When load is given in the second observation, then there is a slight depression at the middle of the beam. While rotating to toss the small hanger, we have to see that how many times this 25 crosses this scale, this linear scale. If it doesn't cross, then the rotation will be 0. Now I am rotating and I am watching at the same time whether 25 crosses or not this linear scale. Slowly I am rotating till the bulb glows. Now it starts blinking. So here now bulb glows and 25 has not crossed. Now the reading is exactly in between 30 and 31. So is 31 just coinciding with the edge of the linear scale. So we will note down 31 as the final reading without any rotation. If 25 has crossed, then we will write rotation 1. But without the rotation, now the reading comes 31. So we will note down final reading as 31 and rotation is 0. Now this 31 becomes initial for the next observation when load will be 1000. So we will note down 31 as the initial of the next observation for 1000 gram. Now we will provide this load, this is 500 gram, and slowly, gently, without any external force from our hand, we will provide it slowly. So I am rotating now and watching at the same time whether 31 crosses this linear scale or not till the glow comes. Yes, bulb glows. 31 has not crossed. Now 71 circular scale reading is 71 and without rotation. So 71 will be the final reading, and this 71 will be taken as the initial for the next observation for 1500 gram. So we will provide the next load gently, then after go on rotating in clockwise direction slowly till the glow of light comes. And at the same time we have to watch the rotations, that is 71 has crossed or not. Now the reading comes 92. So we will note down 92 as the final reading and rotation is 0. We will find the depression for 2000 after giving some time. Yes, it starts blinking. Now a constant glow comes and 92 has not crossed. Now the reading is 33. we will note down 33 as the final reading for 2000 gram load without any rotation. Now this 33 becomes initial for the next, that is 2500 gram. That is the last load to be given. Now the reading is 50. So final reading of 2000 gram load is 50 without any rotation. So in this way we will continue for load increasing side. Then after we will proceed for load decreasing to get the values more accurate. Now whatever reading comes at the last observation, that is the final reading of for 2500 gram, that will be the initial reading of sixth observation or last observation for load decreasing. That is both initial and final we have to note down as 50, because we have not withdrawn any load at 2500 gram load. The condition is same, light is glowing, and we will note it down for load decreasing column as initial and final. So before you remove the load, the condition is the reading of circular scale is 50. So when I remove one load, the load becomes 2000. So before 2000, the reading is 50. So 50 divisions, that is initial reading of 2000 gram load, we will note it down as 50. Now I have removed this load and load becomes now 2000. Still bulb is glowing because contact is now going on. Now after the same time, I have to do this circular scale rotating in the reverse direction till light is off. So when I rotate in the reverse direction, that means in anti-clockwise direction, I have to see whatever reading it is now for 2000, whether that reading has crossed this reference scale or not. If it doesn't cross, then rotations will be 0. And when light will be off, we will note down the reading again from the circular scale. So now we will rotate in reverse direction, and at the same time I have to watch whether 50 crosses this reference scale or not till light is off. Yes, light is off now. 50 has not crossed. So this is 31. We have to note down. This is the second load removed. So rotate it, and I have to watch whether 31 crosses or not. 31 has not crossed. Yes, bulb is now off, and the reading is 11. So final reading is 11 without any rotation. And this 11 becomes the initial reading for 1000. I will remove another load now, slowly and gently. So this is the load 500 which is withdrawn. And now the bulb glows. There is a contact now in between the central leg and the small hanger where load is provided. I have to give same time, and then after I will rotate in the anti-clockwise direction till bulb is off. At the same time I have to watch rotation. That means 11 how many times crosses the reference scale. It should be completely off. Yes, it is off now, and 11 has not crossed. Now the reading is 95. In between 95 and 96, this reference scale is present. So we will note down 95, the previous mark. That is the final reading for 1000, and rotation is 0. This 95 becomes the initial reading for 500 gram. This is the other load which is removed. Contact comes and bulb glues. It has not crossed. Yes, bulb is off now, and yes, reading is 87. Carefully you have to find. 87 is the final reading for 500 gram and without any rotation. And this 87 becomes initial reading for dead load 0. So this is the last load, that is the long hanger which is to be withdrawn. So this is the last load, 500 gram, which is withdrawn, and now there is no load, 0 load is here, dead load now, and there is a contact. I have to rotate it in the reverse direction after the same time, and I have to watch this value of 87 whether crosses this reference scale or not. If crosses, then we will note down the number of rotations, how many times it crosses. If it doesn't cross, then rotation will be 0, and after the bulb is off, we will note down the reading from the circular scale with respect to this linear scale. That will be the final reading for dead load. I am rotating now in anti-clockwise. Bulb is off. It is, yes, little more rotations will be given, and 87 I have to watch. No, 87 has not crossed. Yes, now the reading is 55. So final reading will be 55. If you give more time, then it will be in contact and bulb will glue. So the same time should be given at each observation while providing the loads and withdrawing the loads. Then after, our job is over and we will complete the table. So whatever data we got from our experiment, we will enter into a table that is given in our manual. This is the first column, load M in grams, which is given here in terms of 500 gram. Initially at the first observation, dead load was there. There is no load initially. At this condition, the reading was found. Then in each interval, 500 gram is load provided and corresponding readings are taken. Initial reading, complete rotation, final. Everywhere we have got rotation 0. And after you find initial, complete rotations and final reading, these are all from the circular scale. That is why in short it is written I. This is initial circular scale reading. This is number of rotations. This is final circular scale reading. And next column is I difference F. Here I minus F, because circular scale is rotated in clockwise. That is why this is I minus F. So we will do subtraction. F, this value will be subtracted from I. If I anywhere it is less, then I will be added with 100, because in the circular scale there are 100 divisions. That is why I will be added 100, then f will be subtracted from I, where I is less than f. Otherwise, simply it can be subtracted. So 25 difference is 0. 25 minus 31, here it is less, that is why 100 plus this, that is 125 minus 31, 94. Then 31 minus 71, here it is also less, so add 100, then subtract, it gives 60. 71 minus 92, it is also less, adding 100, then subtraction will be done and gives 79. In this way, I minus f will be found out. Then x is difference plus n into 100. Everywhere n is 0, number of rotations. So the same column, whatever we get in I minus f, that will be entered here. Then this value, that is the small a, this is very important. This is the diffraction value for each load. So initially load was 0, so there is no depression. When load is given 500, this is the number of divisions, 94 circular scale divisions we got. And after 500, again the next observation is 1000. For that 154 number of divisions on the circular scale we got. So how do we find this value of A? This is simply a cumulative addition factor. This is first value is 0, then 0 plus 94, it gives 94. Then 94 plus 60, this is 154. Because all the final values are coming over the initial value of the next one. That is why this value is going on adding cumulatively. So 0 plus 94, 94. 94 plus 60, 154. 154 plus 79, 233. Then 233 plus 59, this is 292. 292 plus 83, this gives 375. In this way, we will be adding so cumulative addition will be done here. So this is the last 375 number of divisions we got when load is 2500 gram. So now the last value I have already told you, this final value, whatever it gives, that will be coming over here for load decreasing. That is the last observation. That is why 50 is the final value for the last observation when load is 2500. So 50 is coming over here as initial and final. Then when load is removed, one load, then it becomes 2000. That is why this 50 is coming over here as initial value. Because at a 2000 gram, the load after we withdraw, we will find the depression. So before that, the reading was 50. That is why it is written 50. So after the load is removed and after some time, the final reading is taken after rotating in anti-clockwise. So this type of readings we got in our experiment. Now f minus I we will find, because here circular scale is rotated in the reverse direction. That is why we will do the calculation for f minus I, not I minus f, because the rotation is simply reverse. That is why I will be subtracted from f. Here 55 minus 87, it is less here, so f will be added 100. 155 minus 87, this gives 68. Similarly, 187 minus 95, this gives 92. Here 95 minus 11, you can subtract, so there is no need to add 100 to f. So simply subtract 84. Then 11 minus 31, here it is less, so add 100 to f. 111 minus 31, this gives 80. Then 131 minus 50, 81, and this is simply 0. Then f minus I plus n into 100, here n is also 0 everywhere. That is why the same column will be entered here. And this is the value of depression, that is in terms of number of divisions on the circular scale after the load is removed. So you can see this last value when the depression was at 375 number of divisions on the circular scale, when the load was 2500, this will be entered here. Last value, 375 is coming over here. Now we will go on subtracting from the bottom to the top. Here we have done by adding cumulatively from top to bottom, but in this case we will go for subtraction from bottom to top cumulatively. That means here the last value is 375 minus 81. It is minus. Here it is simply plus. We are going on adding, but here we are going on subtracting from bottom to top, not from top to bottom. So 375 minus this, 294. 294 minus 80 gives 14. Then 214 minus 84, 130. 130 minus 92, 38. Then 38 minus 68, that gives minus 30. So in this way, we will, whatever comes, that is whether positive or negative, not to be worried, because this is the zero load. So after you get A and B in terms of circular scale divisions, now we will find its average and multiplying with least count of the spirometer. In the spirometer, there are 100 divisions. Circular scale divisions is 100, and in the linear scale, that is 1 MSD or LSD, linear scale division, is 0.1 centimeter. So each by 100 divisions on the circular scale, that gives you least count of the spirometer. So 0.1 divided by 100, that gives you 0.001 centimeter. That is why here least count is multiplied. This least count is here 0.001 centimeter for spirometer, because in one rotation of the circular scale, the distance covered is 1 mm or 0.1 centimeter. That is why pitch is 0.1. In this way, least count is calculated. That gives you 0.001 centimeter. So A plus B by 2. This is A, this is B. Take its average, multiply with a least count. That gives you the values like this. So here, this is the depression column, delta, which takes the important role, using which we will find the slope, that is m by delta. So this column is important, and here we have to ignore this value while plotting a graph. First observation should not be taken, because this is, whether it is negative or positive, whatever, we should not take the reading for zero load. Only these observations will be taken in the graph. There are 5 observations here. So plot a graph.
तो थर्ड टेबल समझ में आया?
Yes, sir.
Yes, sir.
और फिल अप करो थर्ड टेबल.
Yes, sir.
This third table is very, very important, in fact. If you are doing mistake here, then the whole experiment is ruined.
Sir. Hello.
सर
हाँ बोलो.
सर जो हम लोग थर्ड टेबल है उसमें एफ की वैल्यू नेक्स्ट आई की वैल्यू बनेगी ना, मतलब दोनों कंसेक्यूटिव रहेंगे सर सारे में.
हाँ.
तो सर जो मेरा फिफ्थ एक्सपेरिमेंट है उसमें थर्ड की एफ वैल्यू है 64, बट फोर्थ की आई वैल्यू है 62. दोनों कंसेक्यूटिव नहीं है.
कौन सा वर्ड के लिए?
Yes, sir.
फिफ्थ वन सर.
Sir, 5.
सेट 5.
यस सर.
Sir, step 5 नहीं, assignment 5.
असाइनमेंट 5. लेट मी चेक.
Yes, sir.
ओके सर.
सर
रुको थोड़ा, मैं इसको चेक करके देता हूँ.
ठीक है सर.
क्या प्रॉब्लम है बोलो.
प्रॉब्लम नहीं है सर, पूछना था.
पूछो.
सर जो मतलब ये सर वीडियो में बताया गया, फर्स्ट ग्राफ में सर फर्स्ट रीडिंग नहीं लेना है.
ना.
सर ये वाला समझ में, ग्राफ वाला थोड़ा पार्ट बता दीजिएगा सर।
वो ग्राफ अभी रन करेंगे ना।
ठीक है सर, ठीक है सर।
ठीक है, उसको 64 कर दो।
ओके सर।
Okay, sir.
टेबल कंप्लीट हुआ?
नहीं सर, नहीं।
Yes, sir.
16 हुआ है और 2-3 मिनट के बाद बिट स्टार्ट।
सर
बोल।
सर जो ऑब्जर्वेशन नंबर 1 में मेरा वो जो लोड डिक्रीजिंग में बी का वैल्यू पॉजिटिव आ रहा है, चलेगा ना सर?
क्या?
मतलब जो बी का वैल्यू ना यहाँ पर सर जैसे -30 आ रहा है मेरा
हाँ,
पॉजिटिव।
क्या हुआ तो क्या हुआ?
अच्छा अच्छा सर, वही पूछ रहा था सर।
कंप्लीट?
नहीं सर, एक मिनट रुकिए।
सर डिप्रेशन को 3 डेसिमल पॉइंट तक लेना है क्या?
3 डेसिमल।
ओके सर।
कंप्लीट।
हाँ सर।
तो ग्राफ प्लॉट रन कर रहे हैं, ठीक है।
Taking this, so I am plotting the graph here. By taking this load along x-axis and depression along y-axis, we will plot the graph and we will find the straight line graph. So here, before we plot a graph, first of all, we will count the number of blocks available in both axes, x-axis and y-axis. According to the availability of number of blocks, we will see the readings first, the maximum value and the minimum value for the depression. Similarly, the minimum value and the maximum value for loads. Then after we will calibrate, we will accommodate these values along x-axis and y-axis such a way that the entire graph can be utilized. Otherwise, it will be squeezed and graph will give us a wrong slope. So, we will first find the scale, and the name on the graph must be mentioned at the top of the graph paper. This graph is, that is, depression delta versus mass, that is M graph. That is the heading of the graph. It must be mentioned at the top of the graph sheet. Then, after we count the number of blocks, we know in a graph paper, generally there are 20 big blocks along x-axis, and similarly along y-axis, there are more than 25 big blocks along y-axis. So we have to utilize these maximum number of boxes available along the axis. So that is why we have to choose a proper scale, and we will mention along x-axis, we can see the starting load is 0 and maximum load is 2500. So as there are 20 big blocks present along x-axis, so we may choose 3 big blocks is equal to 500 gram, or 30 small boxes, because in one big box there are 10 small scale divisions. That is why this is 30 small scale divisions is equal to 500 gram. So we will find in this way. This is starting with 0 origin. This is 500, then 1000, then 1500, then 2000, then 2500. This is, and we will mention the x-axis, that is mass M in gram, because we have taken in gram these loads. That is to be mentioned along x-axis by giving an arrow mark. So if we take like this, then the whole x-axis can be covered. Similarly, along y-axis, we have to see here the minimum value. We should not take for 0 load, because at a dead load or 0 load, there should not be any depression. Whatever it comes in the experiment, that is to be ignored. We will start from 500 gram to 2500 gram. So here, if we take in this way along y-axis 0.1, that is 5 big box. 5 big box, if you take 0.1 cm, then it will cover up to 0.4, because there are 25 big box. So 5 in this way if you take, then it will cover the y-axis, that is 0.1, 0.2, 0.3, 0.4, 0.5. So maximum is 0.4, because 0.375 is the maximum value. So by considering this maximum value, we will calibrate this y-axis, and in order to find the whole value, because it is 0.375, and this is 0.293. So 3 decimal places are coming along the depression column. So if we find the whole value and we want to plot it in the graph paper, then it is more preferable to take this decimal place forward up to 2 places, so that it becomes 6.6 into 10 to the power minus 2. This is 14.2 into 10 to the power minus 2. This is 22.3 into 10 to the power minus 2. This is 29.3 into 10 to the power minus 2. And this is 37.5 into 10 to the power minus 2. That means the whole value is taken, it is considered along y-axis, and it is taken in the graph up to 3 decimal places. Now everywhere 10 to the power minus 2 is common. So along y-axis we may write this. Along y-axis, if we choose the scale, then one big box, this is 1, 2, 3, we can start here 2, 4, 6, 8. In this way, we will go up to 40, because we will use 20 big boxes, because our last value is 37.5, so we can take up to 40. So along y-axis, if I take the scale, then it is one big box is equal to 2 into 10 to the power minus 2 cm, because everywhere 10 to the power minus 2 is taken. So one big box, if I take 2, then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. In this way, it will go and up to 40, because 37.5 is the maximum value. So it will be more easier and it will be more accurate. So then after we mention the scale properly at the extreme right top corner of the graph sheet, then we will plot a graph. Here 3 big box is 500 gram. So one small box, that gives you 16.66 into 10 to the power 16.66, that is gram. And similarly here, dividing by 10, that is 0.2 into 10 to the power minus 2. We can write one small box, that is 2 by 10, because one big box is having 10 SSD. So one SSD or one small division, small box, becomes 0.2 into 10 to the power minus 2 cm. So clearly it is to be mentioned in the scale. Unless we mention the scale, graph is coming to be incorrect. Then after we plot these 5 points. This is 37.5 for 2500 gram. After we mention the scale, then we will plot the points. So we will find the points for 2500. Somewhere we will find, that is 37.5.
Excuse me, sir.
We will find somewhere.
Excuse me, sir.
सर थोड़ा वीडियो पीछे ले जाइए।
सर, नेगेटिव वाले का ग्राफ नीचे से स्टार्ट होगा फिर।
फर्स्ट वैल्यू नहीं लेनी है हमें।
Similarly, 29.5 will be more easier to plot. 29.5 will find. 22.3 will find. Then 14.2. It is for 500. Then 1000. Then 1500. Then 2000. Then 2500. This is, and we will mention the x-axis, that is mass m in gram, because we have taken in gram these loads. That is to be mentioned along x-axis by giving an arrow mark. So if we take like this, then the whole x-axis can be covered. Similarly, along y-axis, we have to see here the minimum value. We should not take for zero load, because at a dead load or zero load, there should not be any depression. Whatever it comes in the experiment, that is to be ignored. We will start from 500 gram to 2500 gram. So here, if we take in this way along y-axis 0.1, that is 5 big box. 5 big box, if you take 0.1 cm, then it will cover up to 0.4, because there are 25 big box. So 5 in this way, if you take, then it will cover the y-axis. That is 0.1, 0.2, 0.3, 0.4, 0.5. So maximum is 0.4, because 0.375 is the maximum value. So by considering this maximum value, we will calibrate this y-axis, and in order to find the whole value, because this value is 0.375 and this is 0.293, so 3 decimal places are coming along the depression column. So if we find the whole value and we want to plot it in the graph paper, then it is more preferable to take this decimal place forward up to 2 places, so that it becomes 6.6 into 10 to the power minus 2. This is 14.2 into 10 to the power minus 2. This is 22.3 into 10 to the power minus 2. This is 29.3 into 10 to the power minus 2. And this is 37.5 into 10 to the power minus 2. That means the whole value is taken, it is considered along y-axis, and it is taken in the graph up to 3 decimal places. Now everywhere 10 to the power minus 2 is common. So along y-axis we may write this. Along y-axis, if we choose the scale, then one big box is 1, 2, 3. We can start here 2, 4, 6, 8. In this way, we will go up to 40, because we will use 20 big boxes, because our last value is 37.5, so we can take up to 40. So along y-axis, if I take the scale, then it is one big box is equal to 2 into 10 to the power minus 2 cm, because everywhere 10 to the power minus 2 is taken. So one big box, if I take 2, then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. In this way, it will go and up to 40, because 37.5 is the maximum value. So it will be more easier and it will be more accurate. So then after we mention the scale properly at the extreme right top corner of the graph sheet, then we will plot a graph. Here 3 big box is 500 gram. So one small box, that gives you 16.66 into 10 to the power 16.66, that is gram. And similarly here, dividing by 10, that is 0.2 into 10 to the power minus 2. We can write one small box, that is 2 by 10, because one big box is having 10 SSD. So one SSD or one small division, small box, becomes 0.2 into 10 to the power minus 2 cm. So clearly it is to be mentioned in the scale. Unless we mention the scale, graph is coming to be incorrect. Then after we plot these 5 points. This is 37.5 for 2500 gram. After we mention the scale, then we will plot the points. So we will find the points For 2500, somewhere we will find, that is 37.5, we will find somewhere. Similarly, 29.3, it will be more easier to plot it. 29.3 we will find. Then 22.3 we will find. Then 14.2, that is 14.2, it is for 1000. Then 6.6, that is for 500 gram. So we will plot like this. So after we get this set of points, we will encircle them properly, and we should not mention their coordinates. Not necessary to mention the coordinates of each points. After we find these points, we will draw a line in such a way that it will come to the origin, not connecting all points. That is, it may connect a few points, 2-3 points, and 1-2 points may be deviating from the line on either side, but line must come to the origin. So after we draw these, after we find the line, straight line, then it is coming to the origin, because in the working formula it is very much clear that y equals to mglq divided by 4 bdq delta. So why it is coming to the origin and why it will be connected to the origin, we can see here. Then if we see, then delta becomes glq divided by 4 bdq y multiplied with m. So these values are constant. The length of the beam is taken constant for a particular beam. B breadth, D thickness, and Young's modulus all are constant here for a particular set of arrangement. So delta depends the mass, which is clear from the observations. Delta changes with respect to the load. So delta is depending on m. So it clearly indicates the equation of a straight line, that is y equals to kx, where k is the constant, this factor, and x is the variable, that is m. So this y is referred to as delta, which is taken along y-axis. So it indicates the equation of a straight line passing through the origin. So line must be connected to the origin in such a way that maximum points will be on the line and some few points may be deviating from the line on either sides. So that is the most statistical arrangement of a straight line in a graph paper. Then after we plot the line properly, we will choose 2 random points from the line, not from the data points which we have got. Suppose I will take this point, because all the points are on the line are satisfied. So this is a random point and this is another point. These 2 arbitrary points I will take to find the slope, and its coordinates should be mentioned. Let it be x2, y2, and here this point is x1, y1. So I will draw a normal to x-axis from both points, and from this point again I will draw the normal to y-axis. So this value, that is y2 minus y1, this value, this is the slope. From these 2 random points we will find the slope, y2 minus x1, and this is x2, this is x1. So this value is x2 minus x1, and this is y1, this is y2. So slope, clearly it should be mentioned in the graph paper, y2 minus y1 divided by x2 minus x1. We should not measure it with the ruler. We will measure from the scale that we have taken in the graph. So this is, if I take A, this is B, this is C, then BC divided by AB, that is delta del M. This is the value from depression column. So del delta, this is del M. So we will find the slope exactly from these points, and after you find the slope, its unit must be mentioned, because depression is having, this is depression delta along y axis in cm, mass m in gram along x axis, delta, that is the depression in cm along y axis. So this value is y2 minus x1, that is del delta divided by del m, and after you get it, its unit will be mentioned, that is cm per gram. Then after we will come to the working formula, where y, that is the Young's modulus of the beam, is equal to GLQ divided by 4 BDQ multiplied with m by delta. So we have got the slope, that is delta by m. Take its reciprocal, that is 1 by slope we will find, which is m by delta, that is gram per cm we will find, and we will put it here. Then after we will find the value of y, that is the Young's modulus of the material of the beam. Here G we know, we will put it in CGS system, because all the values are coming in CGS system. So G will put 980 cm per second square. Then L we have taken 76 cm. B we have got 2.55 cm, that is the breadth, and thickness we have got 0.5 cm. Then m by delta that we got from our graph. Then after we will find the value of Young's modulus, that is in dyne per cm square, because it is in CGS system, and in SI system it is Newton per meter square. So it will be mentioned in CGS system, dyne per cm square, and its standard value is around 8 into 22 into 10 to the power 11, that is dyne per cm square. This is the range, maybe 18.5, maybe 19, maybe 21, like that. So this is the range. Within that we will find our
तो समझ में आया ग्राफ?
यस सर, वो पावर -2 करके ले सकते हैं ना?
नहीं माइनस को, जो जीरो थ्रोट का रीडिंग बिल्कुल लेना नहीं, और ग्राफ बेस्ट फिट ग्राफ ऑरिजिन से पास करना जरूरी नहीं है, बेस्ट फिट ग्राफ।
सर सर
हाँ
sir, Ananya Chaudhary just messaged me, sir, you have removed him from the meet, sir.
क्या मेल?
हाँ सर, उसने बोला कि सर उसको मीट से रिमूव कर दिया गया है। उसने मेरे को अभी व्हाट्सएप में डीएम किया सर।
मुझे तो मालूम नहीं, मैं तो बिल्कुल लैपटॉप को हाथ नहीं लगाया।
हाँ अभी दिखाया भी
सर, अभी दिखाया भी सर मीट में।
व्हाट्सएप ग्रुप में भेजा है आपको
सर, वो लगता है सर गलती से रिमूव हो गई सर, वो वापस भी नहीं आ पाएगी।
हाँ ये सर, वो वापस ज्वाइन भी नहीं कर पाएगी सर मीट।
तो विश्वास सर को बोलो उसको ऐड कर, दोबारा ऐड कर।
नहीं सर, वो एक बार अगर कोई मीटिंग से निकाल देता है ना सर,
तो
जब तक ये रीमीट मतलब वो अगले क्लास में वो ज्वाइन कर पाएगी।
यस सर।
मुझे मालूम नहीं है, मैं तो बिल्कुल नहीं।
दूसरा क्या हुआ
सर वो
सर
अनन्या सर
आपने शायद
अपने
सर
मीट से
गलती
निकाल
से
दी।
अनन्या चौधरी को सर मीट से निकाल दिया सर।
कौन?
सर
आपने?
अच्छा होस्ट आप सर।
मैं कैसे निकाला, कब निकाला?
सर
अभी
पता नहीं
वो
ग्लिच हो गया
उन्होंने-
होगा, पता नहीं, लेकिन वो मतलब
Excuse
लिखा
me,
है उसका
sir.
रिमूव्स है।
एक्सक्यूज मी सर।
हाँ बोल।
सर बहुत बार ऐसा ग्लिच होता है तो दिखाता है कि होस्ट हैज रिमूव्ड द पर्सन, बट ऐसा होता नहीं है।
तो वो सर
तो
रिफंड
उसको बोलो और एक बार कोशिश करे ज्वाइन करने के लिए।
सर
मैं
ट्राई
क्यों
कर
रिमूव करूंगा?
नहीं कर पा रही।
इतना
मतलब सर
प्यारे
वो
बच्चे
ग्लिच
जो
हो गया
मेरे
होगा
लिए
सर,
उनको
हम बता
रिमूव
रहे हैं।
करके क्या फायदा मेरा?
अरे नहीं सर,
सर,
मतलब
हम-
कभी कभी ग्लिच होता है सर।
सर हम बता रहे हैं सर ग्लिच हो गया है ऐसा कि वो दिखा रहा है कि
उसको
आपने
बोलो,
उसको-
उसको बोलो और एक बार वो ज्वाइन करे।
उसको वो लिंक दे दो, वो ज्वाइन करेंगे।
दे दो।
नहीं हो रहा है तो फिर उसको बोलो दूसरे ईमेल से ज्वाइन
दूसरे
करे, मैं
account।
अलाउ कर दूंगा।
ओके
सर वो अपने सर कीट आईडी से फिर से ज्वाइन नहीं कर पा रही है सर।
और उसका
तो
पर्सनल
उसको
आईडी से बोलो
दूसरे
दोनों
Yes,
के
sir.
लिए।
मेल आईडी
Yes,
से
sir.
ज्वाइन
Yes, sir.
करेगा, मैं अलाउ कर दूंगा।
यस सर, यस सर।
तो ग्राफ समझ में आया?
हाँ सर।
और तो ग्राफ पर
यस सर, ग्राफ समझ में आ गया सर।
सर सर वो जो वैल्यू क्या लेना है सर, जो एल का डी का, वो थोड़ा बता देंगे कैसे?
तुम्हें जैसा ठीक लगे, 10 to the power -2 के लेने से जो डिप्रेशन को लेने की जरूरत नहीं है। तुम्हें जैसे इजी लगे तुम लो।
सर लेंथ एल का पूछ, सर एल का पूछ।
ग्राफ शुड बी मोर देन 80% पेज कवर होना चाहिए। तुम कैसे लेना है लो।
एल का भाई, एल का वैल्यू दिया हुआ है, लेंथ बिटवीन द नाइफ, वही एल का वैल्यू है।
एल 0, एल तो नहीं है वो। लोड
लेंथ ऑफ द
500,
बीम
1000,
नहीं
15,000, 1500 सॉरी।
सर अनन्या को पर्सनल आईडी से अलाउ कर दीजिए।
सर एक डाउट था सर।
हाँ शिवम बोलो।
सर स्लोप तो हम लोग पॉइंट पे नहीं ले सकते हैं ना?
हाँ
पॉइंट जो मतलब ये हमारा लेंथ वाला पॉइंट है सर, उस पे डिप्रेशन वाला पॉइंट है, उस पे स्लोप नहीं ले सकते ना?
स्लोप के मतलब y2 - y1 by x2 - x1।
हाँ तो सर वो जो पॉइंट आ रहा है डिप्रेशन का, उस पे हम लोग नहीं ले सकते हैं ना, अलग लेना पड़ेगा?
आर्बिट्ररी पॉइंट से लेना है।
ओके ओके सर।
सर अनन्या को पर्सनल आईडी से अलाउ कर दीजिए सर।
विश्वाल सर
ଆଜ୍ଞା
सत्य ताको अलाउ कर दियो अनन्या को पिला कहउछन कोन से
कहीं इसका आसी नहीं बोलो।
से तो आसीनी सर।
अरे उसको बोलो, वो आने से मैं अलाउ कर दूंगा ना।
यस सर, शी इज आस्किंग टू ज्वाइन।
ओ यार रुक।
सर आप एक बार रीज्वाइन करिए सर।
जो टेबल है वो 2 × 10⁻⁻² लेके करना है ना? सर 0 से पास हो रहा है तो कोई प्रॉब्लम नहीं है ना सर?
कुछ प्रॉब्लम नहीं है, बहुत अच्छा है।
But I am really confused with the next slide.
Theoretically ओरिजिन से पास करना जरूरी है।
Some number on the entropy axis. It is given. But it's delta S. It's the difference in entropy.
सुप्रिया सर एक्चुअली मैं यहाँ पे लाभ क्लास में बैठा हूँ, बहुत सारे चीज मिस हो गया, कुछ स्टूडेंट रिलेटेड इश्यू जो क्या था आपका क्वेश्चन सर?
Are you measuring the entropy experimentally? Like, is there any procedure you can measure entropy experimentally?
Actually, here we are concerned more about the electrocaloric materials, and whenever you keep the material in isothermal condition and give some stimuli, the heat evolved can be estimated, and that helps you to measure the entropy. So you are keeping the material under certain conditions so that simple mathematical formulas can be used to calculate the entropy change there. Practically here, I have not heard your all questions because here some disturbances occur. What problem I start, this is a new field to me also. What the problem was like this: suppose you have produced some kind of large disorderness in the material, That may be due to disorderness in the orientation of the dipoles, electric or magnetic. That may be due to disorderness in the composition. That may be disorderness in the ionic radii, etc. And suppose that material has some property like possessing high dipole moment or something like that, and giving external stimuli is changing the polarization level or something large. That helps you have some practical applications. So because I wanted to enter into that, I selected it and have decided to include that.
Not necessarily a regular crystal structure, is it?
No, of course, regular means low entropy.
Exactly. That's what I understood. That so you have sort of an amorphous kind of.
Exactly. You can not.
Actually, what Supriya sir asked is which parameter we can measure. That means experimentally which parameter you can measure so that you can calculate the
Entropy. Yes, of course. That is what I wanted.
like you are theoretically like you have some reasoning that okay I am doping it with maybe more than 5 materials, so I am considering it as
High disorder material.
that's fine.
No, not only that, sir. Not only that, you can produce disorderness also in some other ways also, like orientation of the dipole moments, etc., electric or magnetic, or some other properties. I can think. This is the beginning actually. But entropy you can measure through some experimental arrangements like DSC, etc., differential scanning calorimetry, where specific it all these things are having there in the formulas. We are working on that. UV means I have to, and I am thankful very much this way that Suprit first time I think got a platform like this to present. Little bit I have seen she was fumbling. So but I think next time she will do better.
Anyway, so stop here.
Sir, I'm just resigning out. Actually, students in lab class having problem. Okay, sorry, sir. You have any problem?
It will be derived from some other parameters like
Yes, Dilya sir, yes, that is what we are going to do actually.
if you do DSC there, it is possible we can get some.
Yes. We are going to use DSC in fact. Otherwise, we will not be able to calculate that. Our main, whatever problems we have selected, what we are trying to do is we have selected some materials which may show some ferroelectric or something like that high permittivity property. So what we will do, we guess this may happen. Applying an electric field, we are going to see a large change in temperature if this thing is to be done in adiabatic condition. So that is the main motto, in fact. That is why she might have told, I don't know she has told or not, regarding solid state refrigeration.
Okay. Next. Thank you, Suprit. Okay.
Thank you.
Anyone is having any problem here?
No, sir.
No, sir. No problem, sir.
You are feeling comfortable, students?
Yes, sir. Yes, sir.
Yes, sir.
एक्सक्यूज मी सर सर हम लोग को जो ग्राफ है वो सरीक जैसा करना है ना -10⁻⁻2 लेके
समझा नहीं, और एक बार बोलो।
सर वन स्मॉल बॉक्स इज इक्वल टू 0.2 into 10⁻⁻2 लेके करना है ना
जो भी
जैसा
है
सर
वो
के-
उसको हम लोग शायद तुमको सिखाए थे हम कैसे ग्राफ प्लॉट करना है। हाँ, उसमें जीरो लोड वाला जो पॉइंट है ना उसको मत लेना।
हाँ, उसको नहीं लेंगे सर
हाँ।
एक्सक्यूज मी सर अगर लोड को हम जीरो से नहीं लेंगे तो फिर जीरो तो नहीं पास होगा।
नहीं, जीरो वाला पॉइंट को मत लेना, वो वहां पे उतना ज्यादा एरर है कि वो तुम्हारा लाइन को भटका देगा। अगर ले भी रहे हो तो उसको उस लाइन के ऊपर मत रखना।
ओके सर।
दैट इज व्हाट आई एम सेइंग।
ओके सर।
सर इंस्ट्रूमेंटल थ्योरी लिखना था ना।
इंस्ट्रूमेंटल थ्योरी हमने, अगर आपको मिला है डाटा इंस्ट्रूमेंटल थ्योरी के लिए, स्लाइड कैलिपर्स का जो डिस्काउंट वगैरह कैलकुलेशन के लिए, हाउ मेनी डिविजन्स ऑफ वर्नियर स्केल coincides with how many divisions of main scale, and how many main scale division is equal to 1 centimeter or 1 inch. All these data are, if you have got, then you have to write. Could you understand this?
Yes, sir. Yes, sir.
Sir, do we need to write the percentage of error?
No, I have told you categorically. You are not attending the classes.
Sorry, sir.
In theory, I told you categorically, Ashish, that
Yes,
if
sir.
you are not giving the exact value, how can you determine the percentage of error?
सर टिके 2 मिनिट मुझे सेपट लागू आसुची।
नहीं, किसी नहीं सर, किसी नहीं। If you are not giving the exact value of the, quantity, then how can you measure?
Yes, sir. I thought the standard value was not given. Fine, sir. Fine.